All right, welcome. Today we're going to be digital detectives. You know all those little frustrations you run into online? A click that goes to a dead end, a button that just sits there? Well, we're going to investigate and uncover the hidden reasons why that stuff happens. So let's get right into it. We have all been there, right? You're on a site, you click something that seems important, and nothing. Crickets. Or you get that dreaded page not found error. It turns out these aren't just random glitches. Nope, they're actually clues. And today, we're going to follow those clues to understand the invisible world that makes the web work and, well, sometimes break.
So here's our case file. First up, we're hunting down the cause of vanishing pages. Then we're going undercover to explore a really hidden part of websites called the shadow DOM. After that, we'll decode the mystery of those stubborn, unclickable icons. And finally, we'll wrap it all up and see why any of this detective work actually matters. Okay, let's start with a scene we all know too well. You click a link, and the page you were expecting is just gone. It's a classic broken link, but the real mystery isn't what we see. It's what's happening behind the curtain.
Think about it this way. Every single time you click a link, you're basically putting in an order at a restaurant. You're the client, and you're sending your order to the kitchen, which is the website's server. You're asking for a specific dish, in this case, a web page. Simple enough, right? So a broken link is really just the kitchen sending a message back saying, "Sorry, we're all out of that dish." The server looked for the web page you asked for, but it couldn't find it. The resource just isn't there. So instead of the page, it sends back an error. Okay, but here's where it gets interesting. You and I, we see a big 404 not found page. But an automated testing program, it doesn't have eyes. It can't see the error page. So how in the world does it know, for sure, that the link is broken? It needs a different kind of clue. And that clue is a number, specifically the number 400. It's part of a secret code that web servers use to talk to each other. And the rule is actually super simple. When a server responds to a request, it sends back a status code. If that code is anything less than 400, it means success. Here's the page you wanted. But if that code is 400 or higher, like the famous 404, it's a crystal clear signal. Error. The link is broken. No need to see a thing. So just like that, the mystery of the vanishing page is solved. The surefire way to tell if a link is truly broken is to check its HTTP status code. If it's 400 or more, you've got your culprit. Case closed. All right, our next case takes us a little deeper. We're not just looking at a page, we're going inside its very structure. We're on the hunt for things hidden in a secret compartment, you could say, known as the shadow DOM. So before we can understand the shadow DOM, we gotta talk about the regular DOM. The DOM, or Document Object Model, is basically the blueprint for any web page. It organizes all the headers, paragraphs, and buttons into a logical tree structure. Normally, everything on the page is on this one main blueprint. But the shadow DOM, it's a whole different animal. It's like a room within a room, a DOM hidden inside the main DOM. And it's so sealed off that standard tools people use to navigate websites like XPath, they just don't work there. It's like a black box. So you might be wondering, why on earth would developers build something so complicated and hidden? Well, it really comes down to one big thing: performance. Instead of loading one gigantic blueprint all at once, which can make a site feel slow, the Shadow DOM lets the page load in smaller, more organized chunks. It keeps things tidy and makes the website feel way faster for you. So how do you find something that's tucked away inside this secret room? Well, you can't just walk in. You have to follow a specific path. First, you have to find the shadow host. That's like the main building. From there, you get access to the shadow root. Think of that as the door to the secret room. And only then can you actually get inside and find what you're looking for. And that's our solution right there. To get to the stuff hidden inside the shadow DOM, you have to follow the chain of command, navigating that hierarchy step by step, from the outer host, through the root, and to the element inside. And now for our final case, the mystery of the unclickable icon. We see them everywhere, right? Little magnifying glasses for a search bar, a gear for settings. But for some reason, the automated programs that test websites just can't seem to click on them. What's going on? The first big clue is figuring out what these icons actually are. A lot of the time, they aren't just simple images like a JPG file. They're what we call SVG elements, which stands for Scalable Vector Graphics. And here's the key. SVGs aren't pictures. They're actually code, just like a button or a piece of text on the page.
Okay, but if they're just code, what's the big deal? Why are these seemingly simple little icons so tough for automated tests to even see, let alone click on?
The problem is that SVGs are built differently. That standard tool, XPath, that works for almost everything else on a web page, it often just doesn't know how to talk to them properly. It's kind of like trying to open a special lock with a regular house key. It just won't fit. You need a secret password, a special key. And here it is. This is the secret key. It's a special function that specifically checks what an element is called. So by telling your program to find something where the name of is exactly SVG, you're basically giving it the magic password it needs to find that icon.
And boom, that's the solution. To get a hold of those tricky SVG icons, you can't just use the standard approach. You have to add that special name function to target them the right way.
So, we've cracked the case of the vanishing pages, we've explored the hidden rooms of the Shadow DOM, and we've decoded unclickable icons. So what's the big takeaway from all this detective work? When you look back at our case files, you start to see a pattern, right? For broken links, the answer wasn't what we could see, but a status code from the server. For the Shadow DOM, we had to respect its unique hidden structure. And for SVGs, we needed a special command for a special kind of code. In every single case, the real solution was to look beyond the surface and understand the invisible rules that govern the web. You know, the web can seem so simple when you're just clicking around, but underneath every single one of those clicks is this incredibly complex world of rules, structures, and languages. We only uncovered a few of them today. It really makes you wonder, what other invisible forces are out there, quietly shaping how you experience the digital world every single day? Something to think about. Thanks for joining me on this one.